Alright, alright. What's up mga kachimek? Ano? Yan, pag atinista talaga, usually nag-start sa alright. O nun magta-transition ng so, ayan. A tip also, they used word like no para magmukha raw convincing ang words mo. So, na-adapt ko na rin. At the end of the sentence you're uttering, you always say no, no. But don't count kung ilang beses na no ang masasabi ko ngayon. Because naging subconscious ko na siya or unconsciously ko na siya ina-utter. Anyways, we're down to another episode of our laboratory session. And don't get confused because our lecture and laboratory are seemingly separate. Though they are connected. They are related to each other. We are already in chemical formula in our lecture. But in our laboratory, we are still in the separation techniques. 1 unit lang kasi sa laboratory, so usually lag talaga siya na, or it's left behind the sessions. So anyways, for today's session, we are going to talk about the different separation techniques. No, we are going to describe them, and also we are going to give at least one example per separation technique. But before we do that, we have to recall the properties of matter. So without further ado, para hindi na umaba ang video, let's do this. Alright! So ayan na naman tayo sa ating transitional word na alright. So ayan, as I said, now we have to recall first the different properties of matter. Though the properties are divided into two, the physical and chemical, no, hopefully you have already learned and understood some. No, we have to rediscuss them, no, or not rediscuss technically, but to have a glimpse once again, because they are really important on separating the mixtures. No, these properties are very important to understand, to know how do we separate our mixtures in the laboratory. First are the physical properties, no, some of which are the conductivity, electrical and thermal. So when we talk about electrical conductivity, it has to do with something with the electrons, while thermal, no, simply heat. Like sa electrical conductivity, does water conduct electricity? Sa heat naman, bakit umiinit yung spoon when I'm taking a cup of coffee? So those are your conductivity. We also have the density, property which is described by an equation, m over v, or mass over volume, where the more massive object settles at the bottom, while the less massive or less dense rather. Let me reiterate that. The denser object settles at the bottom, while the less dense object, or the densest or the least dense, stays at the top, no, or floats. So that's our density. We also have some physical properties like solubility, the ability of something to be dissolved in another substance, like a coffee dissolving in water, no, a sugar being dissolved in water, salt being dissolved in water, and so on and so forth. Malleability as well. One of the most famous example of malleability is gold, or a material which is very malleable is gold, because we can hammer them and change it into various shapes. That's why gold is one of the most important metal in the world. Also, we have the magnetic attraction, the ability of a metal to be attracted to another metal. More physical properties include the melting point, no, when a solid turns into liquid because the temperature rise. We also have the luster, or the shine of an object, no, gaano siya kakintab, and also the boiling point. No, at what temperature does this liquid boils, no, or evaporates? So these are properties that we have to look out and we have to understand, so that we know how to we can it can help us separate the mixtures, no, that we are going to talk about in a bit, no, or we are going to encounter inside the laboratory. And take note that these physical properties does not change the identity of the substance. We also learned the intensive and extensive properties. Hopefully, you still remember them. These are some of your physical properties. Change the property that might change but will not that will be forever in a substance, no? Si intensive, hindi siya magbabago kahit anong gawin mo sa amount, no matter how you add them or decrease them, how much you poured into or how much you removed from that object, no, that property, physical property, would not change. While the extensive, it depends on the amount, but nonetheless, it does. Both the intensive and extensive are physical properties, and they do not change the identity of a substance, unlike the chemical property, no, which is an identity theft, no, or magnanakaw ng identity, because there's always a new substance form. And some of the examples of chemical properties is, of course, flammability. Yan. And then, we also have reactivity, the ability, usually sa oxygen, and the ability to rust and ability to tarnish. Ano pinagkaiba ng ability to rust at ni ability to tarnish? Si ability to rust is connected or related with oxygen. Usually, something become rusty when it's exposed to oxygen. Usually, water, because water is composed of hydrogen and oxygen, so that's why our metal rust. Tarnishes naman, it simply changes in color. Not necessarily it requires oxygen. It can be other chemicals. Na flammability, of course, then reactivity. These are your 4 chemical properties. So that's just a refresher, so that we would understand, no, how to separate compound, or particularly mixture. No, in our session, we are just going to talk about mixture, no, because the basic techniques talks simply about the techniques on how to separate the mixture. So we are going to talk about their physical properties, no, not the chemical properties. So alright. So what do we mean by these separation techniques? According to the crash course pack, these are your physical methods used to separate different components mixtures. Now, why do we say physical methods? Because we are simply dealing with mixtures, no, which are physically combined. So we don't need chemical means in separating them. So this is your summary of the separating techniques. This is what we are going to run down for this session. No. First things first, magnetism. So, how do we use a magnet to separate mixture? A magnetism can be used to separate a magnetic substance from a non-magnetic substance. An example here is a mixture of a sugar and iron fillings. No, sana all may fillings. Pero gugustuhin mo ba kasi iron, no, metal ang fillings niya. So, manhid siya. So, nonetheless, question, sir, bakit pinagalo yung sugar and metal? I don't know as well. No? We've been doing the laboratory for 3 years, even as a student, so technically more or 5 years. I ask myself as well, ma'am, yung sa laboratory ko siya, ma'am Gigi, bakit magkasama to? Bakit mo ihalo ang sugar sa metal? No, but for the practice purposes, ito yung usual na ginagawa natin sa laboratory. No, we separate. Sometimes sulfur ang ginagamit, no, and iron fillings, because we know that the iron fillings are magnetically attracted. No, they are attracted to magnet, while the sulfur are not, or sulfur is not. Therefore, we can separate these two mixtures. May question doon dati, how would you separate the 3-in-1 coffee? So, let me leave it to you right now. Habang nagpo-proceed tayo, pero isipin nyo muna mamaya. Paano mo masaseparate si milk, si sugar, and then si cream sa 3-in-1 coffee? Because we can't do magnetism there. So this is one of example of magnetism. And maybe as a child, I don't know if it's appropriate to tell you this because most of you are rich kids, so you don't have the chance to experience this one. Now, when I was a kid, I've been applying magnetism, even though I haven't learned it yet. Inside our home, there's a magnet from an old radio, yung mga speaker baga na ang lalaki. Tatalian ko lang yan, and then I'll walk around our backyard, no, even our neighbor's backyard, quiet lang kayo. Tapos, hindi na ako yuyuko para pulutin yung mga pako. The magnet will collect the metals, no, the nails themselves, para sa kalakal, para may pangdota. Alright, mga chimek. That's an application that I learned. I also have watched how my lola use magnets. No, I don't know why rice before, yung bigas, because when we talk about rice, kahit luto or hilaw, bigas, no, I don't know why there are metals, no, but the rocks in the rice are actually being removed by magnet. No, yung mga hindi na re-remove, tinotoss nila. No? That's the magic of it. No? Even without learning the science yet, we are already applying magnetism. The second one is, an application rather. No? Hindi pa pala second one. Some mining industry would separate magnetic materials to none, di ba? If you have been in mining industry, yung mga rocks, dust, pebbles, hindi mahirap yan isa-isahin. So they are using a big magnetic chamber, no, a magnetic machine, so that those that are good metals will be attracted to the magnet, and the separating technique or the separation technique would be very easy for them. Alright, the next one is the filtration. No, we use this to separate an insoluble substance from a soluble substance. When do we use filtration? We sometimes use filtration when we have a mixture that is hetero, 'di ba? Either a suspension or a colloid. Now, most probably a suspension. And then those substance, insoluble substance, are very small. So take note of that, because later on sa decantation, pwedeng gamitin kasi either si decantation or si filtration. Kasi filtration, we use them to separate a soluble substance into an insoluble substance. So this is a simple setup of let me use a marker of a filtration. No, you have the beaker, yan, nasasalo, diba? And then your funnel. Hopefully you still remember your equipments, no, your activities, and then another beaker. So we pour the mixture. So it says here it's a mixture of solid and liquid. We don't know what that liquid is. Might probably, halimbawa, as simply sand and water in the beach. You want to separate the sand and get your beach water. So, ganun yung gagawin. And you add a filter paper here. No, it looks like a very ordinary paper na parang coupon band siyang texture na a substance 20, yung medyo makapal-kapal na band paper. So, we actually have a process on creating this circular form. No, hopefully, we can do the laboratory so that I can teach you how to do it. And then you poured it so that, the insoluble substance will settle here. Now, this insoluble substance, the liquid that passes through here, it's what we call the filtrate. No, we call it the filtrate, or the product that has been filtered, while the insoluble substance that remains here in your filter paper are what we call the residue. No, so isulat natin. So this is your bad color, and that's your residue, while this is your filtrate. That's your filtration process. What are the examples of filtration? So this is the actual setup in a laboratory. Some examples of filtration inside our home are, yan, may animation pa pala. So yan yung residue. Or when we are milking, or separating the coconut meat to the coconut cream or coconut milk, or we are making lemonade that we don't want to include the pulp or the seeds of our lemon. So I don't know. I've watched a video of Uncle Roger, if you know him. No, he's bashing some chefs in America. They're actually filtering rice. No, but we don't do that in the Philippines. So, yan, some of the applications of the filtration. Next separation technique is evaporation. So it's very simple. From the name itself, we simply add heat to your substance or to your solution. No, we usually do this in our solution. Ang example dito is the salt solution, meaning it's a combination of water and salt, probably a seawater. No, to separate the salt from the water. No, we are not after yet sa water, or depende, no, if you want to get the water once again, you have to cover, no, and you have to undergo distillation process. No, that's a separation technique. But when we simply talk about evaporation, we are after the dissolved solid, no, from a mixture, specifically from a solvent. So ang kailangan natin dito is salt. So we simply throw away the water by evaporating them. And whatever remains, usually ito sana yung ginagawa nyo sa laboratory. Ang gagawin nyo is inside an evaporating disk or an evaporating dish, you are going to place salt solution and then simply add heat until the water evaporates from it. And what will remain are crystal salts. And you let them dry and you'll have back your salts. So this is one of the examples of separation technique, evaporation. We separate a solute from a solvent in a solution by evaporating the solvent. So this is usually the setup. But again, we can change this into different things. Usually we use an iron stand with an iron ring in it or an iron clamp, depende kung ano yung gagamitin mong equipment or apparatus for evaporation. And then we don't use anymore the Bunsen burner, but rather we use the Tyrrell burner. No, kung beaker at madami yung liquid, we use the Tyrrell burner kasi we need more heat and more gas. But if simply we are going to evaporate a few amount of liquid in an evaporating dish, maybe, no, we simply need a wire gauze and an alcohol lamp. No, that would do, and an iron ring with an iron stand, of course. So there you have it, the setup for heating a solution, no, to conduct an evaporation. How do we use evaporation? Some of you in your video are correct when cooking, no, especially rice. Diba? We don't want the water in the rice, so we evaporate them. In a salt company or salt production, I can't get the right term. Salt, salt area, salt production, something. And they simply pour some seawater here, or probably merong I haven't seen an actual one. No? Parang may patubig dyan from the sea. They let them dry. And then there you have it, the salt. No? Pinapala lang nila yan. And the rock salts are being made. And even drying our clothes, diba? Our clothes are considered insoluble. So we wash them and we evaporate the water inside them. So the next example of physical properties or a physical separation technique is decantation. So what do we mean by decantation? This is a faster way in separating an insoluble solid or an insoluble from a solvent. No? Different siya kay filtration. Bakit? The insoluble here is actually in medium or large size. No? Or we actually have a bigger residue, if you might call it. Diba? Si filtration, ginagamit natin kapag maliliit yung mga insoluble that may mga makakalusot na if we try to actually use the decantation technique. But here, we can simply separate, and we're not really after the liquid, but we are after the insoluble solid here. Anong example nito? Simply boiling egg, 'di ba? I don't know if you will still use your liquid there, or the water you used to boil your egg, pero we're not after that, so we simply pour them. And it's not necessary that we drain out really the liquid, as long as we can get our egg. Hopefully you get the point and the difference of decantation from filtration. You can filter them, but again, if there's an easier way, like a decantation, and a more appropriate way, you will use this one. So some other examples of decantation. Ito naman, maliliit. So I think this image is actually wrong, but it depends, no? If these are so heavy or heavy solid like nails, that you can pour the liquid without the nails joining the liquid. And again, as I said, now if your liquid is not that important, decantation will do. No need to set up for a filtration. Now inside our houses, Asian people don't filter their rice. They simply use decantation by pouring water so that the rice will remain. And again, we're not after the water, and we're not actually draining the rice. No? Okay lang na may konting matira. But the point is we separate these insoluble objects to the soluble, or to the water, to the liquid. Another example is centrifugation. No? This is a separation technique where we use the property of density. Halimbawa, in our blood, we want to get the RBC. So, in a test tube, si blood, halo-halo yan. So, what the doctors usually do, or in a container, they mix it and then wait for some time so that it will settle. Parang tubig at lana. Diba? Tubig at langis. Yan, para pang pelikula. Hindi mo sila mapagsasama. So, they will settle depending on their density. So, that's how centrifugation works. Usually, we use this in the hospitals. No? So, yan. This is a step-by-step application. So, I'm afraid of blood. So, can I cover? Char. So, I have a blood phobia. But hopefully, you get it. They mix the sample, and then the plasma, the erythrocytes, I don't even know what they are, because I'm not a bio lover. I hate bio because you have to memorize a lot. Anyways, Buffy code. The point is, these are being separated by their density. So, ano pa? Ano pa example? Actually, usually halo-halo yan. Nagnilaga ka. To get the soup or the sabaw, decantation. Diba? Those objects settling at the bottom, like your meats, your patatas, these are an effect of a centrifugation. You don't really shake them. And then, to separate them, you don't need to filter them, and so on and so forth. So, this is your centrifugation, usually inside the hospitals. We also have paper chromatography. So, what do we do in paper chromatography? It is a way to separate colors. Alright. Naglalag. Tchaden! Wala pa rin. So, si paper chromatography, post ko muna. Yan, medyo naglag lang. So, si paper chromatography uses the properties of color in papers to determine things that they want to determine. So, they use the speed of colors in waters, or in water. So, ang example nito, or saan siya ginagamit? Sa police, sa crime, in investigating crime. The policemen are actually using them. So, medyo nawala ako pag naglalag. The policemen are using them in determining powders, liquid, or drugs. Paper chromatography. We also use them in tie-dyes, diba? Waters moving faster. Some colors are moving faster than the others. That's why we can create our art in our t-shirts. even in painting, no, use paper chromatography. So how the color moves, or the speed of the color moves in a moist paper, or a moist object, or a watery surface. And the last one is the distillation. So this is the most complex of all. It's actually separating two or more liquids based on boiling points. No, so this is a combination of evaporation. We also have the distillation, or the capturing of the water. And yan, hopefully the video is done. So I'll insert it here if the video is done. If not, I'll continue. So hopefully let's all watch this. This is the distillation process. Kung hindi naman, hindi ko na flash, so backup plan, kasi hindi ko na edit. So sa distillation, again, we use them to separate objects, especially both liquids with two different boiling points. No, and we cannot see them. Example, halimbawa, we are we have the ethyl alcohol and then your water, or you're simply your alcohol. You want to get the pure ethyl alcohol and you want to remove the water. Diba? Usually in our alcohol, I don't have an alcohol near me. We usually see 40% alcohol or 50% alcohol. Meaning, let's assume there are no other ingredients. Alcohol lang siya tapos water. Kung 40% siya, the rest is 60% water. So I want to check if it's true. So I can get a 100 ml by using a cylinder, a graduated cylinder or a beaker, in measuring an alcohol 100 ml, and then determine the boiling point of ethyl alcohol. Probably that's 70 degrees Celsius. So meaning at 70 degrees Celsius or something like that, near that or after that, pero bago mag 100 degrees Celsius, in my distillation setup, the alcohol are actually evaporating. So mag-evaporate siya by using a thermometer. I can see na 70% na siya. It will become a vapor, and then the vapor will run through here, or the steam, and it will be condensed once again because there's a coolant, or may water na pumapasok as a coolant, to help in the condensing process. And I'll be collecting here my ethyl alcohol, and what would remain before it reach 100 degrees Celsius is my water. So this is not the pure water. Iba atang example dito. So dito, ito yung salt, pure water. So ito yung sinasabi ko kanina, if we simply want the salt, there's no need for this setup, this distillation setup. We simply evaporate the water and bring it to the environment, Diyan na siya sa langit pang dagdag sa ulan. But if we want to collect once again the water, we will use a distillation setup. Now, sir, bakit kailangan pa ng ganito? Pwede naman kung salt lang hinahanap. Actually, this will not really make sense until it will happen to you. Or maybe you can simply imagine. Diba? Imagine you're trapped inside a boat in the middle of the sea, where you don't have a water, or even sa island na lang, sabihin natin. Now, how do you get fresh water aside from waiting sa rain, which might be dangerous, which might be an acid rain, or a rain which might not even come? You can get salt water, or a sea water, but never drink it because it will cause more dehydration. It will kill you. And imagine drinking a salted water. So this is where distillation comes in. By the heat of the sun, or if you can make a flame of your own, you try to evaporate first the seawater so that those steam, these are now your fresh water. Try to capture them. I've seen a setup sa island, madali to kung nasa place ka, pero kung wala kang gamit, ang ginawa niya is he soaked his clothes. I don't know if this is hack that I've watched or a real story of a man. He soaked his clothes, tapos pigdry niya sa init ng araw kasi wala siyang lighter, wala siyang flame, wala din siyang panggatong. And then just a plastic that captures the steam. Yung mga droplets, yun yung water na ginamit niya para makasurvive. No? Even a very small amount of water saved his life. That's how distillation occurs. But in laboratory, we use them to separate compounds with different boiling points. So this is your simple distillation process. So a distillation apparatus looks like this one. I will discuss this if the video works, you don't have to continue in this part anymore. We're already done. But if the video does not work, sige, bibilisan natin ang pag-discuss. So here, you set up your Tyrrell burner. Diba? I've taught you already how to use the Tyrrell burner. You have your iron ring and then iron clamp supporting your distilling flask. So, ano pinagkaiba ni distilling flask kay Florence flask? Diba? Madami tayong flask. Erlenmeyer flask, so on and so forth. So, si Florence flask, wala ito. Itong parang tube connecting. But when we add this tube, where our steam will flow, this becomes now a distillation flask or a distilling flask rather than a Florence flask. We put covering, cork, so that the temperature will hold and the steam will not escape here. So, hindi siya dito lalabas. Dito lang talaga ang daan niya. So, dito siya dadaan. Naka-sealed din yan. Naka-sealed para walang mag-escape na steam. And then, the steam will flow here. No, dito, mali yung linya ko. Dadaan siya dyan. And then, it will be cooled by water source. No? Sa laboratory, walang water. So, hopefully mag-play yung video. We did an alternative to do that. And then, pag cool na siya, it will return to its liquid form and you will receive the pure liquid you are looking for. So, this is part supposedly of your midterms exam in a laboratory. You either set up filtration, you either evaporate something, you either manipulate the Tyrrell burner, or you manipulate the distillation process, or you set up the distillation process. So, magbubunutan sana kayo, and you have to show it to me, 5 minutes, walang magtuturo, hindi ako magsasalita, you just have to show me. But since we cannot do it, hopefully, as we are doing it right now, you are doing it in your mind. So, there you have it, ladies and gentlemen, the distillation, and the rest of the separation techniques. No, ang daming example ni distillation. Ginagamit siya to get your distilled water. Meaning, water without impurities, a water without other chemicals except H2O. No, hydrogen and oxygen. And this water, this kind of water is the one that is not does not conduct electricity. No, hindi ka makukuryente sa distilled water kasi H2O. What makes a tap water or an ordinary water conducts electricity are the impurities like the metals and minerals inside it. So, that's why we have a distilled water, mineral water, ano pa, alkaline water, and tap water. Diba? Madami. Ionized water. So, this is the relevance of separating techniques. And hopefully, you appreciated it more by doing the activity. There you have it, mga kachimek. Maraming salamat. This has been Sir Jello. If you have question, comment down below. And then, hopefully, magawa natin to sa laboratory next semester. Let's pray for a vaccine. Peace out.